Hi, I'm Kevin Holm-Hudson, Associate Professor of Music Theory at the University of Kentucky and author of the textbook Music Theory Remixed, A Balanced Approach for the Practicing Musician, published by Oxford University Press. In Chapter 6 of Music Theory Remixed, we study counterpoint, which has to do with how lines interact one against the other in a musical texture. In the Prelude chapter, we looked at texture, and one of the textures that we studied was polyphony. In counterpoint, we actually get into the specifics of how those different elements in the texture work together. So our first example in counterpoint, and I'm just going to use staff without clef because in this case it doesn't really matter in terms of clef, it's more a matter of direction. But let's say we have one part that moves down like this, and we have another part that is moving up like this. They're moving in opposite directions. This is called contrary motion. If you have one part that moves while the other does not, one part moves, one part stays, this is oblique motion. If you have two parts that are moving in the same direction by the same interval or to the same extent, this is parallel motion. Two parts that move in the same direction but to different degrees is similar motion. And finally, you can have two parts that don't move at all. And even though that might seem like a paradox to label a motion where no motion is happening, we have a name for it. It's called stationary or static motion. So those are the 5 basic voice-leading motions that we consider in counterpoint. And there are a number of regulations about how these particular tones relate to one another, how they are to be used. One of the more controversial prohibitions in counterpoint, or at least it's one that always comes up with students in discussions, involve parallel motion, specifically parallel fifths and parallel octaves. So if we have, for example, a fifth, perfect fifth, going to another perfect fifth, this is parallel motion. It involves 2 perfect fifths, and this is what we call parallel fifths, and this is something that in counterpoint was to be avoided. Likewise, if we have 2 perfect octaves, this would be an example of parallel octaves. Now, we hear parallel fifths and parallel octaves in contemporary music all the time, especially in popular music. And so to our ears, it may sound perfectly normal. Why was it that parallel fifths and parallel octaves were considered so bad in classical counterpoint? The answer has to do, again, with texture. Of our 5 types of motion that we have here, contrary motion was perhaps the preferred motion because it set up a contrapuntal ideal where you had true polyphony, you had true independence of parts. And the more parts you had in a musical texture of this sort, the more of a challenge it is to keep those parts sounding mutually independent from one another. One famous example of this occurs in a 16th century motet by the composer Thomas Tallis, a piece called Spem in Alium, which involves 40 parts, 40 different voices that are moving independently. This is how that piece begins, and I think in just the first, 20, 30 seconds, we have about 8 different parts that are introduced. See how many you can hear. So there's more independence of parts, and the impression is more like a tapestry where you've got individual threads of sound that are woven together very intricately. If you have parallel motion, on the other hand, especially parallel fifths and octaves, the voices tend to fuse together acoustically. It sounds like one thick unit rather than individual parts. Now, in the 20th century, some composers did actually use parallel fifths and octaves for this very effect. The composer Janáček, Czech composer Leos Janáček, wrote a piece called Sinfonietta that was in tribute to his nation's army. He wanted to show strength and he wanted to show power, and he did so at the beginning with parallel fifths. In contemporary rock music, this carries over into power chords, where you have a parallel fifth and octave sounding together as a single unit, and the effect again is monolithic. It's not about interactive parts, it's more about solid blocks of sound. Here's another example. So you can hear how, even though you have 3 voices or 3 parts in that sound, they are all moving together, they fuse together as one block of sound. The composer Philip Glass had rigorous classical training in counterpoint, including how to control contrary motion, similar motion, oblique motion, and so forth. And soon after he finished his studies, he rebelled against all of that with a piece that he called Music in Fifths, which is entirely parallel fifths, and again shows how these 2 voices can fuse together in one sound as they are heard moving in parallel. I'm Kevin Holm-Hudson, and this is Music Theory Remixed. You'll find much more about counterpoint in Chapter 6 of Music Theory Remixed.